Welcome back. In this video, we're going to look at heaps. And to understand the heaps, these are a special type of a data structure that's often used in priority queues and algorithms like heap sort. And by the end of this video, you're going to understand the basics of max heaps and min heaps. And we'll walk through some operations such as insertion and deletion when you're talking about hoops. Or rather, when you're talking about heaps. So, just to get started, you need to understand what a heap is. And a heap is basically a binary tree that satisfies the heap property. We've already looked at binary trees, and there are two types of heaps. We have a max heap and we have a min heap. And the key difference between the two is that for max heap, the value of each parent node is greater than or equal to the values of its children. So this is an example of a max heap, and here as you can see, this is the value of the parent node, and it's greater than this the child node, so it could be equal to the child nodes. While when you're talking about a minimum heap or a min heap, the value of each parent node is less than or equal to the values of its children. So as you can see here, this is the parent node or the root node, and its value is bigger than these other nodes, or rather smaller than or less than these other values. And one thing to know about these heaps is that we often store them as arrays so that they're easier to access. Or it's easier to access basically their elements using indices, and the root element is always at index 0. Now, just to look at this in more details, we're going to start with the max heap structure. Now, talking of the max heap structure, in a max heap, like you've seen, the largest element is always at the root. And as we know, this is the root element, and that is the largest element for max heap. And how it basically works is that for any node I, so for any node I in a max heap, the parent is at index I minus 1, then divided by 2. So this is what happens for any node I. And okay, we can just write this here so it's easier to understand. So we're saying that for any node I, the parent is always at index I minus 1 and divided by 2. So it's at index I minus 1 divided by 2. And this is for the parent index. Then we also have the left index. The left index, or rather the left child, is always at index 2 multiplied by I plus 1. This is where we're going to find the left child, and the right child is going to be this 2 multiplied by I, but now it's going to be 2 multiplied by I, but now it's going to be plus 2. This is for the right child. So what we have here, this is going to be the parent. I should be using this. This is going to be this is the parent, this is the left child, and this is the right child. An example is when you have a max heap represented as an array, it will look like this. So we're going to have an array, and it's going to have, let's say you have 50, we have 30, and then we have 40, 10, and 20. So if we look at this, the parent is going to be at I minus 1 divided by 2, right? And basically what this means is that the root node is going to be this 50 here. This is going to be the root node, and it is larger than its children, and its children are 30 and 40. And each subsequent node contains a heap property, basically, from what you can see here. Now, the other structure is the minimum heap or the min heap structure, And just to in contrast, the mean heap ensures that the smallest element is always at the root. And you've already seen that here, that the smallest element is always at the root. And how this would look like in a heap structure, we can just copy paste this and change. So how that is going to look like is it's going to look almost opposite of this. So we're going to start with 10, 20, then we're going to have 30, and here we're going to have 50, and finally 40. So as you can see here, 10 is the root, and it's smaller than its children, 20 and 30, and the heap property is maintained basically throughout this, right? And that is basically the difference between the min heap and the max heap. Now, moving forward, we can just look at some of the operations that can be carried out, and we can start with an insertion operation. So, talking of an insertion operation, how this is going to look like is that when we insert an element into a heap, we first place it at the end of the array or the last available node in a tree. So if this is the array that we're dealing with, we're going to, or if this is the array, I can even use this one here. What we'll do here, let's say we're going to insert the element we're going to insert to basically place the element at the end of the array or the last available node in a tree. So if these are the nodes, if this is the last available node, we're going to insert it there. And then after that, after we've done that, we're going to bubble it up basically, or heapify it up to maintain the heap property. Again, remember the heap properties. We have the max heap and the min heap structures that we need to follow. So either of the two. So if we want to insert an element like 45, what we're going to do is we add 45 at the end, then we compare it with the parent. So let's say we add 45 here at the end. Then what we do now is we compare it with its parent, right? So its parent is going to be like 30. Yeah. Then since 45 is larger, we're going to swap the two. Then after doing the swap, after doing the swap between this 45 and 30, so we're going to have 45 here. 45 is going to take this place, and then let's say we make 30 here at the end for now. Then we're going to compare with the next parent. The next parent is 50, and since 45 is smaller than 50, then basically the heap property is restored. So now we're going to have 50, 45, 40, 10. Then we're going to compare this to, so this 30 should be here. So we're going to have 30 here, and the 20 is going to be here. And this is basically the insertion operation has worked like that. The next operation we're going to look at is a deletion operation. So for deletion, I'm going to just say like this. So for a deletion operation, basically, this is when you want to delete delete basically the root element maybe, and which is usually the most important operation in heaps, this deletion. And when you talk of both the max and the minimum, the main heaps, we always remove the root, which is either the largest or the smallest element, depending on the type of heap structure that we're looking at. So there are three steps that we look at when it comes to deletion. The first step that we look at is we replace the root with the last element in the heap. So replace root with last element, the last element in the heap. After replacing this, the next thing we do is we just remove the last element. We remove the last element. And finally, after removing the last element, we basically heapify down or bubble it down in other ways so that you can maintain the heap property. So basically, you say heapify down to maintain heap property. The heap property. There should be an O here, like that, and there should be an F. Well, so we heapify to do that. So an example for this is let's say we want to remove 50 from our max heap. So let's say this in this max heap that we have here, we want to remove 50, and let's have it down here. If you want to remove 50, we basically replace 50 with 20, and 20 is the last element that we have here. Then we remove 50. Now, then we're going to compare 20 with its children. Then we're going to basically swap 20 with the largest child, which is going to be 45. Then check if the heap property is maintained, and we proceed like that. So at the end of the day, we're going to end up with this looking like this. After you've removed 50, we're going to have 45. Then here we're going to have 30. We'll finally have 40, and then we'll have 10 and 20 here. So we'll have 10, 20. This is after we've swapped, then we start heapifying down. Basically, we swap, remove the last element, then we start heapifying down. And this is how it's going to look like finally. So from what we've seen right now, we've looked at how min and max heaps work basically, and how you can do the main operation, insertion and deletion. And you've seen when it comes to min heap, you have the smallest element, or the element with the less value is the one that is at the root. But with the max heap, you have that the largest element is the one that is at the root, and then everything else follows. The same thing is going to happen when we talk of a subtree in a heap basically. And that is it. Thank you for watching this far. I'll see you in the next one.